Hi everyone. In this mini lecture I'm going to be talking about the solutions to a couple of questions that should help you with question number 4 on the exam. Okay, so basically what you're going to be doing is you're going to be filling in a function that takes a number list and is going to produce the first number in the list that meets a certain condition. So you're going to be filling in the while, right? And you might often think of this as an until, but you're going to have to rewrite it as a while. And remember what I said in the previous or the mini lecture for the previous solution. I said a while is really just an until not. So if you know what you should be putting in for the until, just put a not in front of that and you'll get the condition for the while here, right? And as you can see here, it's going to take the item, right? So first let me just go through this here. This is going to be getting the index of your answer. So this is going to go through every single index in the list, right? So remember, range takes two numbers. The first number is the number you start with, and the second thing you put in, it's going to stop one before that. So the last index of a list, right, the position of the last item in a list is going to be at one less than the length, since it starts with 0, right? So like in this example, we have num list, you have at index 0, 1, 2, 3, 4, right? And there are 5 numbers in the list, right? Okay, and each time the accumulator is just going to be num list of index plus 1, right? We don't really care what the accumulator is going to be here. We're not using it in any meaningful way, but what you're going to see is when you actually draw the table, the items themselves are just going to be the indices 0, 1, 2, 3, etc. And the way I set this up is that the accumulator is going to always be the number that's at that index. So you could see you're starting with an accumulator of num list 0, and your item or your index here starts at 0. And then your next accumulator is going to be, since index is going to be 0 here, your next accumulator is going to be num list of 0 plus 1. It's going to be the next number in the list, right? So it's going to be in this case, the number that's at index 1, right? And then the next time you go, you're going to be, index is going to be 1, and so you're going to get the accumulator is going to be the number at index 2, and then your index here, or your item, is going to move up to 2. So you're going to see if you actually run this here, the table that's drawn is showing your index in the right column and your number in the left column, right? But again, you're really just going to be using the index with the answers that I give you, right? Okay, so how are you supposed to do this? So as I said, the point is to first think about when you want to stop. So you want to stop when you reach a positive multiple of 5, right? So that says two things. It says it's positive and it's a multiple of 5, right? So you want an and here, right? So you want to stop when num list of index is greater than 0 and num list of index %5 is equal to 0, right? That means that the remainder when you divide by 5 is 0, so it's a multiple of 5, right? So that's when you want to stop, right? And remember that since this is a while, right, that means you want to continue while it's not true, right? So remember, just put a not in front of what you want to put for until. So here, this is what we wanted to put in the until. Num list of index is greater than 0, and num list of index %5 is equal to 0, right? It's a positive multiple of 5, but since we're doing a while, we put a not in front of it, right? So this would be one of our answers. Now I said to use De Morgan's laws to get the other one, right? So if you're saying it's not the case that both num list is index is greater than 0 and num list of index is divisible by 5, then you're saying that num list of index is not greater than 0, or num list of index is not a multiple of 5, right? So you could sort of think about distributing the nots, right? And it changes an and to an or. So I really want you to do this before you look at the answers, because the answers look, pretty similar. The point is to just make it so that when you write it, you don't actually like mistype something. Of course, you should check your code anyway, to see that it runs correctly. But it was just a way of conveniently making it so you could just select the options instead of actually having to type them in. And also just making sure that you type in both answers here, right? So one is just the answer that you get by taking the until, the condition you would put for an until, and put a not in front of it, and the other is to apply De Morgan's laws to that. But again, since a lot of the answers look similar, I want you to first figure out what it is, maybe write it on paper, and then select the answer choices that are the same. So we said we're looking for not numList index is greater than 0, or not numList index %5 is equal to 0, and that's this one here, right? So notice the not, with the way the parentheses are applied, the not is being applied to just this, the not is being applied to just this, and we have the or in between, right? So some of the other ones you have to be careful because you have to see where the not is being applied. In this case, the not is being applied to the whole thing, right? Okay, so let's look at the second one. So this one we're trying to find the first integer that's even or prime, right? So again, our until would be number is divisible by 2 or the number is prime. Is prime is not built into JavaScript, but you have that in text to code. So we're looking for numList index is prime or numList of index is even, right? Divisible by 2, a remainder when you divide by 2 is 0. So that's this. And again, since we're doing a while, so we want to stop when we find a number that's prime or even. So put a not in front of it, and that will be when we want to continue, right? So if we want to stop when this is true, we're going to want to continue while the whole thing is not true, right? Okay, and then we use De Morgan's laws to get the other answer here. So not of numList index is prime or numList of index is even is saying it's not prime and it's not even, right? So it's neither prime nor even, so it means the number is not prime and it's not even, right? That's when we would be continuing. So we're looking for numList index is prime, or sorry, not prime, right? This one says it is prime. This one has an or, right? We're looking for an and. This one says numList index is divisible by 2. So here we go, right here. So numList of index is prime, or it's not prime, and numList of index is not divisible by 2. Okay, so for these questions, again, very straightforward, hopefully. Just take whatever the condition is. So whenever you want to stop, so here you want to stop when it's even or prime. So you take that, you put a not in front of it, and then you just apply De Morgan's laws to get the other one. So not numList is prime or numList, not numList of index is prime or numList of index is even means is the equivalent to, or logically equivalent to, not numList of index is prime and not numList of index is even. And the other one, we wanted to stop when we had something that was a positive multiple of 5, so it's a multiple of 5 and it's positive. So we wanted to stop when numList of index is greater than 0 and numList of index is divisible by 5. So we want to continue while that's not true. And then again, applying De Morgan's laws, we get not positive or not divisible by 5. Okay, so hopefully that's pretty straightforward. You can expect that for the exam question. And yeah.